Hi, welcome to Chapter 5. Chapter 5 we're going to get into what they call repetition, or what I will basically talking about are loops, and that's where we can actually do the same code over and over and over again, depending on how many times we need to do something. So the first part of the chapter talks about, okay, so we get the amount of the sales, display the amount of sales, input sales, so we calculate the commission. Then we display the commission. Then we get the amount of the sales. So here we have a bunch of sequence coding lines of code that we do it over and over and over again. Now again, the problem with doing that is it's just like using modules. We never ever want to repeat the same amount of code. Okay. Now earlier I talked about making sure that we always put things in modules if we need to repeat them again or do them again. Well, in this particular case, we're going to repeat the same amount of or the same sequence of code over and over again. So instead of doing that, let's put it in a loop process and maybe call a module. So that's kind of what this particular first section is talking about. So loop and flowcharting looks a lot like a decision structure, but it's not, because what it's doing is we have some condition. If it's true, we do some type of coding or statements, whatever the case may be, some processing, and then we come back up and go above the diamond. So we're actually going to repeat that particular condition again. If that condition is still true, we're going to keep doing these statements and keep looping around until that condition becomes false. Now it's very important that with that condition there is something being set inside of the loop that will eventually get that to be false, or we'll end up what's called an endless loop. Okay, so the first particular loop we're going to cover today is what is called a while loop, and it says while this statement is true, do this. Okay, and so let's take a look. So let's first just do this. Let me open up Raptor, and going to go ahead and just create a simple loop. And I'm going to go ahead and create a variable called x, and I'm going to set it equal to 1. Make sure that I let him know that it is an integer. And then I'm going to do this. I'm going to put in a loop. So I click on a loop process and I click right here. And so now here is the loop. So what I need to do down here is I need to put what is the condition. I'm going to say x less than or equal to 10. I may have done that wrong. X less than or equal to 10. Is that correct? Okay, so here's where Raptor's a little different. Their true loop gets out, and so we're always going to set it to false. So what I'm doing is going to basically that's the yes loop. So I want to say x greater than 10. So thinking about Raptor, always think about those things that are we're going to keep doing these things while it's false. Once it's true, we're going to get out. So we want to put in a false statement here. I'm going to say greater than 10. Okay. So now inside this loop, I'm going to put an out statement that basically just displays x. Okay. Now, right now, this loop's going to go on forever. So what I have to do is I have to put something in there that does something that will eventually make that condition true. So in this case, what I'm going to do, I'm going to put an assignment in there right after the display that says x equals x plus 1. So each time we're going to add 1 to the x until eventually it will end the program. Okay. So first time through it's a 1. We display the 1. We add 1 to it. Now it's a 2. We come back around. It says, is x greater than 10? No, it's not. We go and display x, which is 2. We add 1 to it. It's a 3. so on and so forth. So I go ahead and run this, and there it did. It went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then basically dropped out. Now here's my question, is if I were to put a display, put it down there. If I were to put a display and print X right here, what's going to be displayed? 10 or 11? Well, here's the deal. So let's say we're at 9. We display 9. We add 1 to it. It's now 10. It comes back around and it comes up and says, is X, which is equal to 10, is 10 greater than 10? No, it's not. So it goes and displays 10. We add 1 to it. It's now 11. It comes back up here to the loop and comes around and says, is 11 greater than 10? Yes, it is. So it drops out of the loop, comes down the yes. When I display this X right here, it's going to be 11. Okay? So I'm going to run it one last time, and sure enough, there is the 11. Okay? So, something to think about. So now let's take a look at the 5.1. So I'm going to go ahead and copy these to my desktop. So we start thinking about loops. The book's going to keep doing while true, and we have to, in Raptor, keep thinking while false. Okay, so just kind of take that concept and make it the exact opposite. So when we create our looping process, we're going to have to make sure that we always think of it in false terms, where they're going to think in true terms. So here's what we've done. Okay, we created a sales variable. It is a real data type. We initialize to 0.0. Commission is 0.0. Keep going is a string, and it's set to the lowercase y. We create a commission rate, which is a constant, and we set it to 0.10. Here's our loop. While keep going is equal no. Okay? Again, we're trying to think in a false statement here. Is keep going equal no right now? No, it's not. So we're going to basically, it's equal to y. So we're going to come in here and we're going to get sales from the user. We are going to then calculate the commission by taking the sales times the commission rate, put that in the commission, and then we're going to display the commission rate. Then we're going to ask, do you want to calculate another? And if we type in a lowercase y, it's going to come around here and is keep going equal no? No, it's equal to y, and it's going to drop out of the entire loop. Okay, so we run this. Amount of sales. I'm going to say yes, I do. Amount of sales. I'm going to say yes, I do. And I'm going to say no, I don't. So commission was 1,000, 2,000, 3,000. Because I chose 10,000, 20,000, 30,000. So the commission is 10% of each one of those. Okay. So as you can see, the loop in this case allowed me to. We're given user control of when do they want to stop the loop process by actually asking them, do you want to keep going, yes or no? And once it's equal to no, we basically drop out. Now in this particular case, we might type a Y, but we really could type a G, an X, or a Z, because that's not equal to the letter N. So that's really going to keep going as well. But in a user's brain, they're looking at Y and N. Now, will a uppercase Y work? No, an uppercase Y will not work, because that is not equal to. I'm sorry, uppercase N would not work. That's equal to a lowercase n. So here's what we got to do. We got to make sure that at some point we could put a check in there whether it's equal to y or n. We will find out later there is an uppercase and lowercase function we can utilize within Raptor to take whatever they give us and make it uppercase or lowercase. Okay, so that's kind of what it talked about there. So the nice thing there is we had a process where we want to get multiple sales and figure out multiple commissions. You know, I could do this for 10, I could do it for 20, I could do it for 8, I could do it for 6, I could just do it for 1 if I needed to. The user types in, do you want to continue, yes or no. So here's in the spotlight. A project currently underway at the Chemical Labs, Inc. requires that a substance be constantly heated in a vat. The technician must check the substance temperature every 15 minutes. If the substance temperature does not exceed 102.5, then the technician does nothing. However, if the temperature is greater than 102.5, the technician must turn down the vat's thermostat. So here's the flow chart that we need to create. We're going to declare some variables. We're going to create a temperature, a constant, which is called max temp, 102.5, and then we get the temperature from the user. We check to see if the temperature is greater than the max temp. Now, again, in this particular case, we're going to say less than or equal to. So if the temperature is less than or equal to the max temp, we're going to display the temperature is too high, display turn the thermostat down and wait 5 minutes, again, input the temperature, and we're going to keep looping around. Once we get the temperature down below the max temp, we're going to display the temperature is acceptable, check again 15 minutes. We close the program and we turn around and rerun the program in 15 minutes. Okay, so let's go ahead and see what this looks like in Raptor. And so there we have our temperature, which is set to 0.0. It's real. Here is our max temp, which is a constant, set at 102.5, and it's also a real. We get the temperature from the user, and we come in and say, is the temperature less than or equal to the max temp? If it is, we're going to drop out of the loop. If it's not, again, remember, we're always checking a false loop. We want to keep doing on a false loop. And so then we display the temperature is too high, turn down the thermostat, wait again, and enter it here. Wait again and enter it here. Is that what it says? I thought it said wait 5 minutes. Wait 5 minutes. I need to update that. Wait 5 minutes and enter here, and then we get the temperature. So in this particular case, we wait 5 minutes and then we enter the temperature again, and it loops back around and checks to see is it less than the max temp. Okay. So we run it. So it's 108. 108. Why is it not working? Oh, I see why. I'm not looking here. Temperature's too high. Turn the thermostat down, wait 5 minutes, and enter it here. Okay, so we go ahead and we'll say it's 106. That's still too high. Let me put this down. There it is. It's still too high. Okay. So I'll say it's 103. That's still too high. It's 102. So the temperature is not now acceptable. Check again in 15 minutes. Okay. So as you can see, it kept looping until we got the desired temperature, and once we got that, we could basically drop out. Okay, so here is 5.3, and here what we want it to do is we got sales commission, keep going, we got our commission rate. We got keep going if it's keep going equal no. If it is, we're going to keep enter the amount of the sales. Now, you know what I could do is I could actually make this not equal y, which is really what we're trying to check here. So while keep going is not equal y, we're going to enter the amount of sales, get the commission rate, and keep going. Okay? So, similar thing. So, now if you notice, what is wrong with this particular loop? Well, we're not doing anything with keep going here. So we're actually going to be in an infinite loop. We're just going to keep typing, and it will keep going on because we're not giving it a chance to drop out of the loop. Okay? We're not asking the user, do you want to keep going? Keep going is always going to not equal y because y, we set it to y up here. Okay? So, talk about infinite loops. We never want to get there because guess what? The program will run forever. Okay. So let's take a look at 5.4. So double click on 5.4 and here's where we fix it. Okay. I'm gonna fix that again. I'm gonna change that to not equal y. Okay, I'll save it, run it. Amount of sales. Do you want to enter other? Y for yes. I'm going to say, yes, I do. Yes, I do. And no, I don't. And we basically drop out. Okay, so same exact results we got before. Okay, so now we have, so we've talked about a while loop. And a while loop says do while this statement is true or false. In our case, in Raptor, we do it while it's false. There they did it while it was true. Now we have what's called a do while. And how does this work? Well, the do while is a little different. You'll notice the statement is here as opposed to here. What does that do? Well, what's going to happen is that statement's going to be executed at least one time. Okay? Because realize, let me go back up here to this loop. This loop right here is what's called a pre-test loop. If I come in here and this statement is equal to no, it will never go into that loop because it's called a pre-test loop. Where we come down here, even though this is a pre-test loop, we've already executed the statement before we got to the loop. This is called a do while. It's not really any different than a while loop, except we're always going to execute the statement at least once. Okay? Now, we can come in, execute the statement, the state condition is true in this case, we come around and we'll execute that statement again and keep doing this while the statement is true. But even though, so this condition could be false right off the bat, we're still going to execute that statement at least once. Okay? So in pseudocode, we just have the word do, and we execute all that code, and the while test is checked at the end. So that we're going to do all of that at least once, and we'll keep doing it if the statement is basically true in this case, but we're going to do it at least once, and that statement could be false right off the bat. So let's take a look of how that looks in Raptor. And here it is. So here I've got start. Here's keep going is set to a null value. I come in here and the first thing I'm going to do is I call show commission. And show commission is going to basically calculate all of the different commissions. Let's see what we're passing in. We are passing in nothing. Okay. But this is where we set our sales, our commission rate. We get the sales. We then calculate the commission rate, and then we display the commission rate. So it does everything. It does all the commission, and then it comes back and says, do you want to calculate another one? Y for yes, to keep going. This is the way to keep going. Now look, we've already done everything before the loop. So no matter what, even if this was set to no up here, it's still going to do this at least once before it basically goes on. I could set this to no right off the bat, and it will never go into that loop. It will just basically drop out of the loop. So this is a do while, because we're going to do this at least once. So I run it. I say no, and it never went into the loop. We only did it once. Okay. So we put the statements before the check, before the conditional check, so they'll get executed at least once. Okay, and there's certain times when we want that. Maybe we're trying to calculate some type of a percentage depending on sales amounts, and so we at least want to do that once so we can at least get the percentage set correctly before we basically do anything else. And so we may set the commission rate to 0.0. We go into that process, we do it at least once, we set the commission rate, and then we can either loop more or get out of the loop. So we take a look at 5.6. And so 5.6, here we do show retail, where we basically do the same exact thing as the others, where we actually set our variables, we set our constant, we get some information from our user, we calculate, and then we display it. So it's really doing the same thing as the other one. We'll just run through it real quick. So do another set to nothing. So I run this. Enter wholesale cost. We'll say it's $50. Do you want to do another? Yes, I do. Wholesale cost, we'll say is 60, and so it's shown over here that the retail price is 52, the other one's 62. So I go ahead and enter a no here, and so in this case it was going to execute at least once. If I said no right off the bat, it's not going to do any more. Okay. Okay. Now, this is kind of different. We have a do while and do until, and we're not going to see any difference in Raptor, but I just want to talk about this. A do until loop. So a do while loop, it says do while this is true. A do until loop says do this until it becomes true. So a do until says this condition is, I'm expecting it to be false, and I want to do this until it becomes true. Okay? We're not going to see any difference in Raptor because we can only check, because the condition is only drops out when it's true. We only check while it's true. So really, a Raptor loop is a do until. It's a do until loop. Okay? Because we're doing it until it becomes true. A do while says do while it's true. So we're going to see 5.7, and again, we don't have the ability to do this with the do while or do until. So what we can do to kind of get by this is use not logic. So we say here's the password, we're going to loop, we get the password. So this is a do until, because we're going to do this until it becomes true. Okay? Now in this case it's do until it becomes, well, let's try this. So let me take out that not logic, and I'm going to take this guy and place it on the no side. So if the password is equal to that, so that's really a do while. Maybe I should have just left it. Yeah. So this is a do until. So do until it becomes true. Okay, so we're using not logic as our true statement. So while it's not equal that, okay, we're going to keep doing the false, okay. So here is our loop check, our condition. Try again, and then if the password equals equal to that, no. We come back up and loop again. Oh, I'm sorry. My bad. This is the conditional check here. This is just a decision statement. If the password is not Prospero, we say sorry, try again. We come back down here. This is where it actually checks to see, is that statement true? If it's not true, we come back around and do the loop. Okay, my bad. So this is just a conditional. This is the actual loop condition statement. Okay. So rerun this. I type in gibberish. Kind of move this out the way. So this guy says no, sorry, try again. So I type another password, and it comes up and says nope, sorry, try again. So this is where I then type in PROSPERO, and it comes as password confirmed, and then we drop out of the loop and we go on. Okay, so this is not would be a password program you'd want to use. This kind of gives you an idea of how password programs work, because real passwords are going to use an encryption process, whereas a 128-bit encryption, that's a whole nother subject to talk about. But anyways, it's a very, very cryptic type of way that is almost impossible to break that type of encryption. But it uses this process where it keeps asking the user for the password. Now, how many times do we allow a user to type in their password? Well, that's another thing as well. If you give them an infinite amount of time to enter the password, then guess what? There's hackers out there who can actually write a program and just let it run for hours or weeks or months until it gets a password correct. It just keeps throwing all of these uses an algorithm to basically type in a bunch of letters and numbers, and just keep typing in some type of an algorithm to put in maybe letters and numbers and symbols, and just keep in a certain sequence and keep changing that sequence, keep changing until eventually it'll get it right. So in a password program, we'd probably have some type of a counter in here as well, where we would then only allow the user 3 times, and then we drop out. Okay, and now in our main system, we would have some type of a switch saying that they've maxed out too many times, and we would lock this particular username then out until they had to do something to get that reset. Okay, that's just kind of more of a side note. Deciding which loop to use. It says we were introduced 3 types of loops: the condition, while, do while, and do until. You want to use the while loop to repeat a task as long as the condition is true. The while loop is a pre-test loop, meaning that it could essentially not get into the loop. Do until loop is also a pre-test loop, but also performs a task at least once. Okay. And the difference between do while and do until is, do you want to do this while it's true, or do it until it becomes true? Okay. So that's the do while and the do until. How do we do? There's another loop called a for loop. Now the difference between a the do while, do until, and those while loops and a for loop is, a for loop knows how many times it's going to execute this loop. Okay. Now, even though we may be using a variable in that particular case, it still knows how many times. When we go into that loop, it knows how many times it's going to execute. Now, a for loop is going to look the same exact way as a do while loop and Raptor. The way we're going to really know a difference is first we're going to put a comment in there saying this is a for loop, so that if we were to write code from that, we would know which looping process to use. But the main difference is we're always going to have a counter. A counter is going to be the indicator that this is a for loop. Okay, and you'll see here in a little bit. So let's first let's just take a look at the pseudocode. So the pseudocode says for some variable is equal to some starting variable, and then we want to go to some max variable. And while now this is a pretest loop as well, meaning that we could have the chance to not even go inside the loop if that statement is false. So while this statement is true, we're going to come in here and keep looping around. Now the great thing about a for loop, except for Raptor, the great thing about a for loop is it will automatically increment the counter. In Raptor we have to do that manually, but just keep that in mind. So here's what it looks like. We have a counter, it's an integer. We have a max value set to 5. And I say for counter equals 1 to max value. So it says we're going to start at 1 in our counter, and we're going to keep incrementing it by 1 until we get to the max value. So this for loop then starts, so the counter starts at 1. I display hello world. When I hit this N4, think of behind the scene, it automatically adds 1 to the counter. Now the next time through, counter is equal to a 2. Is 2 greater than the max value? No. We display hello world. We add 1 to the counter, it's 3. Is 3 greater than the max value, which is 5? No. We display hello world. We add 1 to the counter, it's a 4. Is 4 greater than the max value? No, it's not. We display hello world. We come down and we add 1 to it. We got 5. Is 5 greater than the max value 5? No. So we display hello world. We add 1 to it. Now 6. We come up. We say is now the counter 6 greater than the max value 5? Yes, it is. We drop out. So it's going to display this 5 times. Okay. Again, in flow charting, we can't do a for loop, but the counter basically is how we indicate that we know that it is a for loop. We've got counter here. Is counter less than the max value? Yes, it is. We display hello world. We add 1 to the counter. Okay. So in this case, we want to do the square of a number 1 through 10. So square is 1, then 2, 3 times 3 is 9, 4 times 4 is 16, so on and so forth. Okay. So here's how it would look like in a for loop within a flow chart. We got our variables declared. We display the number, and then we basically put tab over, and we have our square. We've seen this before, and then we've got our set counter 1, and then we come in here and we have counter less than or equal to max. It is. So we come in, we set the square of the counter time by itself, multiplied by itself. We display that. We display the numeric value and then the squared value. We add 1 to the counter. We come back around. We're going to do this 10 times basically. Okay. So let's take a look at this. And did we ever look at 5.8? What was 5.8? Yeah, okay. This is that counter. So let's look at this example before we get to this one. Notice I put a comment that says for loop because I've got a counter equals 1 and it says it's an integer for the for loop. Our max value is set to 5. That's our constant, and it's an integer as well. So we come into the loop. This counter. Now again, since this is Raptor, we always have to deal with the while it's not true. Okay, while it's not true, because once it becomes true, we drop out. So it's really an until loop. So is the counter greater than the max value? No, it's not. We display hello world. We add one to the counter. We come back around. We keep doing this until we basically get the counter greater than the max value of 5. So I run this, and sure enough, hello world pops in there 5 times. Okay. Now, the great thing about using a constant is, let's say down the road I need to change this. I want this to run probably, I want to do it 8 times. Well, I want to display 8 times. I just changed that to 8, and now when I run it, boom, it now displayed hello world 8 times. Okay. So let's go ahead and open up 9. Let's take a look to see what that looks like. So I've got my counter, I've got my square, which is set to 0, it's an integer. Again, counter's set to 1. Now the reason we always set it to 1, well, it doesn't have to be set to 1. What it has to be set to is whatever starting number you want it to be. Now I could create this variable as counter, set it to 0, and down here right before our loop, set it to 1. Okay, that's a possibility. But I'm just saving a step by just setting it to 1 here. I set my square to 0. My max value is set to 10. Then I say put number space 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 square. This is where I put my dashes, and then here is my for loop. Okay. Now again, we're writing this flow chart to give to a programmer to write code from. So they would see this for loop and know right off the bat that this is going to be a for loop, and so they would code a for loop. Is the counter greater than the max value? No, it's not. So we go ahead and say square is equal to the counter multiplied by itself. We then put the counter space 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 square, and then we add 1 to the counter. So it comes back around and says this counter now 2. Is it greater than the max value of 10? No. Then we go ahead and say square is equal to 2 times 2, which is 4. We display all that. We're going to keep doing that for loop. Now, like I said, a for loop knows how many times it's going to execute. We know by this max value we are going to do this 10 times because we're going to take the counter and multiply by itself. So very easily I run this, and there is the number and the square. There's that dashed line 1 1 2 4 3 9 4 16, so on and so forth, all the way up to 10 and 100. Okay. So it looks like a regular loop, but again we've got a counter involved. Okay, so what if we want to increase it instead of incrementing by 1, I want to increment by 2? Well, in a programming world, there's actually this word called step. And step is the value we're going to increase the counter by. If you leave that step out, it defaults to 1. So if we take a look at this counter, it says for counter equals 1 to max value, which is 11, step 2. So the first time through it's a 1. When we hit this end 4, we go ahead and add 2 to it. It's now 3. Is 3 greater than the max value 11? No. Then we display 3. We hit the end 4 loop, we add 2 to it. It's now 5. Is 5 greater than the max value 11? No, it's not. We go ahead and display it, so on and so forth. Okay. So if we take a look at that in Raptor, it's pretty easy to do, because instead of adding, again, I set my counter to 1. Here's my max value, which is a constant integer set to 11. Here's my loop. I say for loop. Is my counter greater than max value 11? No, it's not. It's 1. I go ahead and display 1, and then I say the counter equals counter plus 2. So this is a step 2. I would probably do something like this, where I would say, I could actually say step 2, just so that we're using the terminology needed for a for loop. Okay, so we run this, and there is 1 3 5 7 9 11. Okay, now realize counter, if I were to display the counter on the outside of this loop on the yes side, it would actually be displaying 13. Because remember, we have to, this has to be false in order for it to drop out. So when I added 2, while counter was 11, I added 2 to it, which is 13, came around and says, is 13 greater than the max value? Yes, it is. We dropped out. Okay. Okay. So here's in the spotlight. We want to do our miles per hour and convert it to, we're going to take kilometers per hour and convert it to miles per hour. And the way we do that, we just take the kilometers per hour multiplied times 0.6214, and it will give us miles per hour. Okay. So we want to keep doing this. We want to show the miles per hour from 60 to 130. But notice it goes 60, 70. So what is our step here? Our step is going to be 10. It's a for loop, step 10. So let's take a look at 511. And so here's our miles per hour, which is our variable, set to 0.0. It's a real. Our kilometers per hour is set to 0. It's an integer. We then put kilometers per hour, space, 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 miles per hour, and our dash. We start our kilometers per hour at 60. We got loop. I say it's a for loop. I come in here and say, well, kilometers per hour, is kilometers per hour greater than 130? No, it's not, because it's set to 60. Then I say miles per hour is equal to kilometers per hour times 0.6214. I then display kilometers per hour, a bunch of spaces, and then miles per hour. Then I say kilometers per hour is equal to kilometers per hour plus 10. Notice I've got my step 10 right here. It comes back around. That's now 70. Is 70 greater than 130? No. Now, I would have done this instead. Is I would have used a constant here. I would have said max underscore speed and set it to 130. And I would have called this a constant integer. And then down here in my conditional check for my loop, it would have said max speed. Okay. That way there, if I need to ever change that inside my program, I can change the constant. And usually we always declare our variables at the top, beginning of our program. So if I wanted to change this to go to 160, I just change it very easily right there in my constant. Okay, so run it. And there it is. Kilometers per hour, miles per hour. There's my dotted line. And 60, 70, 80, 90, 100, all the way up to 130. Did it look that way? Let's see. Yeah, 80.78. Yeah. Okay. Now we could do step a negative number. Let's say I wanted to do a countdown from 10 to 1. Well, I could do a loop starting at 10. My counter's at 10. And while the counter, my conditional check would be, while the counter is greater than 1, greater than 0, sorry. While it's greater than 0, let's do this. And at the bottom, I'm going to say step -1, or counter equals counter minus 1. So if we take a look at 11 or 12, we got our counter, we set it to 1, we got our square set to 0, our upper limit set to 0, and then we get the upper limit from our user. So this program displays numbers starting at 1 and their squares. How high do you want to go? I put an upper limit. Then I put display on the screen the word number, a bunch of spaces and square, and here's my dashed line. Here's my for loop. Counter greater than upper limits. Okay, while the counter is or I'm going to check at the beginning of every loop, is the counter greater than the upper limits? If it isn't, that's false. I go ahead and say square is equal to counter times itself. Then I do the counter and the square itself, and then I add one of the counter. I don't see this how this is different. So, okay, it's just asking how high do I want to go. Let's go ahead and go to 20. And so there's a number squared from 1 to 20. Okay. We look at 513. How is this different? Oh, so 13 is different. It's asking what number you do want to start with. We're not going to start with 1. We're going to start with a different number. So we're going to actually let the user start with a number. Okay. So I don't see how that's any different. Oh, so 20. So we should have asked. That's where I didn't do this properly. So this is where I would set my counter equal to 0. And then in here I would say it wants us, so okay. So we need a new variable, and it's going to be called lower limit. I'm going to set this counter back to 1, by the way. Or am I? No, I'm going to leave that alone. Sorry, my bad. So lower limit set to 0, and that is an integer. And then I'm going to display what number, double quote, yeah, let's just do this. Bear with me. And we will say lower limit. Okay. So now I've asked the user for a lower limit, and then I'm going to what number should I end with? Okay. And then the for loop is going to start with the lower limit and then go to the upper limit. So what I need to do then here is, right before the loop, I need to say counter is equal to lower limit. Okay, so now I've got my lower limit set. I do my upper limit. So now here's what we can do. Like I say, this program displays the numbers and their squares. What number should I start with? We'll say 10. What number should I end with? Let's go to 20. And there it is. There is the squares from 10 to 20. Okay. So we don't have to start with 1 always. We can actually start with a negative number and work up to positive numbers. We could again start with a number like 10. So I could do something like this, where I have my counter. I'm going to set it to 10. And then I'm going to put my loop right here. And again, this is going to be a for loop. And I'm going to say, is the counter less than 1? Okay. And I'm going to then display the counter. And then I'm going to take the counter. It's going to be equal to counter minus 1. So I'll put a comma right here that says step -1. Okay. So when we run this guy, it goes from 10 to 1 and drops out. Now the great thing is, look at counter here. Counter, the last time we did anything with it was set to 0. Because let's say it was a 1 right here. I subtracted 1 from the counter. It's now 0. When it comes back around, it says, is 0 less than 1? Yes, it is. We just basically drop out of the loop. Okay. Okay. A counter-controlled while loop. Okay. So in this particular case, it's basically going to look just like a for loop, except it's basically a while loop. So this while loop says while counter is less than or equal to the max value, we display hello world, then we set the counter equals counter plus 1. Okay, so in Raptor it's going to look identical, but we're going to basically put a comment that says this is a while loop. Okay, so we look at 14. And so really it's no different than what we've seen before. The only difference is we say while loop here, so that when we do have our programmer they're going to write a program from this, they now know to use a while loop as opposed to a for loop. Okay. We look at 515. And so here we have our counter, we have a square, here's our max value is 10, which is a constant. We then display numbers, a bunch of spaces in a square, we put our dashed line. So here is our while loop. So again, this is a while loop, not a for loop. It looks identical. We do our square, we put our counter, and our counter is counters plus 1. So really, this looks no different than a for loop in Raptor. The only difference being is our comment up here we're going to put. So again, we create these flow charts so that we can give it, so we work out the logic and we give it to our user. Now, I don't know if I ever stated this before, but the person creating this flow chart, I don't have to know Python, I don't have to know Java, I don't have to know COBOL, I don't have to know Fortran, I don't have to know R, I don't have to know any language. I just have to know logic. So I work out the logic of the program, I get it to work, and then I give that to the programmer, and they write the code from it. And the programmer then does initial test, but then they give it to the testers to do a full systems test on it. Okay, so that's really what we're doing here, is we're working out the logic before we actually write the program. Okay, let's take a look at 516. And 516 again is a while loop. got a counter, we got our max value set to 11. We're going to basically do that step 2 process again. Now I probably don't need that step 2 in there because that makes it look like a for loop at that point. We don't want that. So here I've got counter, max value. Here's my while loop. It's identical to what we saw before. It's going to run the same exact way. The only difference is I have while loop here so that when I give it to the user or the programmer, they can basically then use a while loop. Okay, I'm expecting them to use a while loop here. Okay. I've already kind of gone over this a little bit, where we can actually decrement, actually go backwards in our loop process. So here I've got my counter set to 10. Here's my min value 1. Here's my loop. I check to see if my counter is less than my min value. While it's not, I go ahead and say I display the counter, and then I do counter equals counter minus 1. So this is where I kind of showed this before. So we run it, and we go from 10 to 1. Okay. Okay, let's see. So in this particular case, we want to create a running total. So let's just go ahead and open the code. So we've got a numeric value, or a variable called number. We set it to 0. We have a total variable set to 0. We've got our counter set to 1. We've got we display to the user. This program calculates the total of 5 numbers. Then we have a for loop. Okay. We check to see is the counter greater than 5. If it's not, we go ahead and go into the loop and we say just get a number from the user. Total is equal to total plus number. We add 1 to the counter. Again, we should have a comment here that says step 1. We come back around. If that statement's not true, we keep doing this until we get to 5. Now again, we probably shouldn't use number 5 here. We should probably use a constant. So we go ahead and run this. I'll say 100, 200, 300, 400, and 500. And it says this program calculates a total of 5 numbers. The total is 1500. Okay. So we use the loop to keep a running total of the numeric values that we get. So now what we're going to use is what's called a sentinel. Now what a sentinel does is we keep asking the user for, in this case, some type of numeric value. Then at some point we're going to have the user type in some value that will basically stop the loop. That's called a sentinel. So it's enter a number to add to a total, enter the number 99 to basically get out. That means stop the program. So 99 won't be added. It will basically cause the loop to basically get out. Okay, so if we take a look at 19, we've got lot number is set to 0. We enter the properties lot number, or enter 0 to end. Okay, so it's an integer numeric value. And we're going to have them enter a 0 once we basically want to stop this loop. So this is a while loop. We come in, and is the lot number equal to 0? If it is, we drop out of the loop. If not, we show the tax. We call this show tax, which basically asks for the property value, asks for the tax value, gets the tax. There's a constant tax factor. We then get the properties value from the user. We calculate the tax, we display the tax, and then we come back to the main. Then we enter the property lot number, and they type in a lot number. It comes back around. If it's equal to 0, if it's not, it keeps on going. So when I run this, so we'll say we're looking at lot number 1023. We type in the value. it displays the tax value. We display, okay, we got 2512 is the next one. 2512 is the next lot number. We type in the value for that. It displays a tax. I type in a 0, which is my sentinel value, and it basically stops the loop, which ends the program. Okay, so sentinels are kind of nice. I don't like them so much. It's kind of a cheesy way to end your loop, but it's usable. But yeah, they're okay to use. I just don't really like them because I think it's kind of a cheesy way. I would like the yes or no or some type of another operator like that, or in a future chapter we'll get into a menu. We actually type in a menu X. I want X or 0 or something to exit the program. But sentinels are okay. I just don't like them. Okay, so now we can have loops inside of loops. We have to be very, very careful with those because realize, as we'll see here in a second, we're actually going to create a clock. So we're going to have seconds and minutes. So think about it. Seconds are going to count to 60, and once they get to 60, it drops out and into the minute loop, and so that minute then has to go. So let's just take a look at it. So here is the program. We got, is that right? Oh, this is number of students. Sorry, my bad. So in this case, this is the program the teacher might use to average students' test scores. The statement line 13 gets. Before I do, let's just do the clock real quick. So I'm going to create hours, set it to 0, minutes, set it to 0, and seconds, set it to 0. Then I'm going to put in a loop, and this loop is going to say, while hours are greater than 23, if that's a yes, we're going to drop out. If it's a no, I'm going to put another loop right here. And this loop is going to check to see, are minutes greater than 60? 59. Well, let's just say greater than or equal to 60. We're going to put another, so if it's yes, we drop out and go into the hours. And we're going to put another loop right here, inside of that loop. And we're going to say while seconds are greater than or equal to 60. So we've got our loops, but now what we have to do is we have to make sure that we put our incrementers in there. So if it's greater than 60, if it's not greater than 60, we are going to set seconds equal to seconds plus 1. Inside of our minutes loop, we need to increment. inside of hours. I say minutes are equal to minutes plus 1. And then hours now, we got a problem right now. And that problem is if hours are less, so in our case we're doing the false side, we have to set our minutes to 0. So we have to kind of reset because once we get 60 minutes, we change the hour, and then we have to increment, we have to set the minutes. So to do that, we have to come in here and say set minutes to 0. And here I'm going to set seconds to 0. Let's see how this works. I'm going to stop it. So here's what I'm going to do. So I'm going to display the hours variable. I'm going to concatenate on a colon, the minutes variable, and then I'm going to concatenate on a colon, and then the seconds variable. I'm going to display that at the very end here. So let's run this again. So I'm going to stop it just so we can come over here and look. So if we look at the very beginning, it was 111, then 112, 113, 114, and it went all the way up to 60, and then it went 121, 122, 123, 124, and it kept going around until it hit 60 again, and then it went 131, 132. It really should be, you know what, I don't think I want 60. I want greater than 59. Is really what I want, 50. Yeah, because I don't want to display 60 because that's the 0 setting. Let's just run it again real quick. As you can see, it would take a long time to just do 1 hour. But notice here's 151, 141, all the way up to 1459, and then it's 151, 152, 15. It's still going to 60, isn't it? But well, let's consider 60 the 0. Yeah. Okay, so there's the clock. Let's take a look at 20. Which is our students. So we've got num students, num test scores. So we're going to have tests inside of, so if we have 5 tests, that's 5 tests per student. And if I got 10 students, there's 5 tests. It's actually we want to do this 50 times. So I got num students 0, num test 0, total 0, score 0.0, average 0.0. How many students do you have? Get the number of students. How many test scores per student? Get the number of test scores. I set my student equal to 1. This is a for loop. While students, if the students are greater than num students, we drop out of the loop. If not, we go into it. We set our total equal to 0. We put our student number. We put student number, space, 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 then student. Put a dotted line. We set our test score equal to 1. We go into another for loop. We get our test, is the test num greater than the test num score? We go ahead and get the score. We add that to the total. We then basically add 1 to the counter. And once it's greater than, we come through here. We know how many times we're doing this. We equal the average by the total score and the number of test scores. We then display that average, then we add 1 to the student. That was just 1 student. Now we come back around and do that all over again. Okay? So, we run it. How many students do you have? Let's say I've got 3. We've got 2 tests per student. I'm trying to make this easy. So test score 1. And here's our next student. So, student number 1, their average test score was 67. Here's student number 2. Average score for the student was 57. Student 3, average score for the student was 67. Okay? So, pretty cool. I think this put really needs to be above there. Yeah. Okay. So that was a nested loop inside of a nested loop. I said we're going to have 3 students, 2 test scores. So we go into each student, do that twice, go to the next student, do it twice, next student, do it twice. So we basically 3 times 2 is 6. We did it 6 times. Okay, so that's it for Chapter 5. Again, if you have any questions, give me a call, contact me in any way you can. Happy to help work with you. And we will see you in Chapter 6.